Today we're going to do problems and solutions of 2.4 exponential function manipulation. Let's start with the first problem. Let f of x be a function on which a transformation occurs. Let g of x a transformation of f. For each problem, name the transformations of f. Now, remember what we have talked about in the previous video, that if you have an f of x that would be equals to b to the power of x plus k, you can see that there is a horizontal translation that is taking place here, that is affecting the x values, shifting to the left k units or shifting to the right. Okay, where b x plus k, where k is shift left or to the right. Remember also that horizontal translation, that in every horizontal translation of an exponential function is equivalent to a vertical dilation. Okay? That is, f of x would become, okay, f of x would become b to the power of x times b to the power of k, where that would be, if we say b to the power of x, b to the k, we put b to the k in front of it, times b to the x as a common factor, a times b to the power of x, where a is equals to b to the power of k. I think this is what we talked about in the previous video. So if you are given f of x equals 2 to the power of x and g of x is equals to f of x over 32, so we could rewrite g of x as f of x. What is our f of x? That is 2 to the power of x over 32. Now, what we're going to do here is to change 32 with the same base as in our numerator, which is 2, wherein we could rewrite 32 as 2 to the power of 5, right? When you divide an exponent, what are we going to do with the exponent? We are going to subtract the exponent. That means this will become 2 to the power of x minus 5. Remember, there is a shifting that is going on here. Since it's negative, that means it shifts to the right, right? Since it's negative, how many units? 5 units to the right. Okay? Let's have number 2. F of x is 5 to the power of x, and g of x is f of x times 125. We're going to rewrite it as g of x. What is our f of x? We're going to substitute that 5 to the power of x times 125. Since we have a base 5 here, we have to change 125 with a base 5. That would be 5 to the power of x, and 125 is 5 to the third power. Okay, using the power property, what are we gonna do when we multiply exponents? We are going to add the exponent. So that would be 5 to the power of x plus 3. since it's plus, that means there is a translation taking place. Shift, since it's plus, it is shifting left 3 units. Okay? All right. Let's do number 3. Before doing that, okay, please be reminded that the power property is there is a horizontal dilation on an exponential. That means we are doing something on the x values. It can be we are multiplying. That means there's a power to a power, whether it will be, when we say horizontal dilation is taking place, wherein in horizontal dilation you have, if you have f of x, that would be b to the power of c times x is an exponent, and there will be a change of the base of the exponential function. It could be written as b to the power of c raised to the x power. And it can be, when we multiply, what happened, it might be stretch or shrink. So there is a horizontal dilation taking place. Okay. Now, if we have this, f of x is equals to 11 to the power of x, and g of x is equals to f of x raised to the negative 1. All right, we can see a negative exponent. So there are several things that is taking place here. You can raise that to a power in, let's say, if we were going to rewrite this, f of x is 11x, right? So we substitute that with 11x to the negative 1. That means it will become 11 to the negative x. What happens if we have negative exponent? We flip it and get, by getting the reciprocal to make the exponent positive. So that means if this happens, there is a reflection. All right? Reflection across the y-axis. All right. Let's do this. F of x equals 7 to the power of x, and g of x equals 49x. So we're going to rewrite 49x with the same base as 7 here. That would be 7 squared raised to the x power. So you have 7 to the power of 2x. There is a horizontal dilation taking place, whether it's stretch or it is what, shrink. Let's have this. F of x equals 6 to the power of x, and g of x is f of x to the power of negative 4. So we have g of x. We're going to rewrite and substitute f of x with 6 to the power of x raised to the negative 4. What happened to that when we multiply? Use power to a power. That would be 6 to the power of negative 4x. And making your exponent positive by flipping it and get the reciprocal, that would be 6 to the power of 4x. So there is a horizontal dilation. All right, of course, in this case. And beside that, there is a reflection across the y-axis. Okay, let's have this. F of x equals 6 to the power of x, and g of x is f of x times 36. So rewrite g of x. What is our f of x? 6 to the power of x equals times 36. We're going to rewrite, okay, 6 to the power of x. We're going to rewrite 36 with the base 6 as 6 to the power of 2. So we're going to do the power property. Add the exponent when you multiply. So this will become 6 to the power of x plus 2. Take note, it's a plus. So there is a shift. When it's plus, it shifts left to unit. Okay? Let's f of x equals 3 to the power of x, and g of x equals f of x to over 27. So let's going to rewrite g of x equals f of x, which is 3 to the power of x. 27, we can rewrite that as with a base 3 to the third power. So this would become, when we divide exponent, we're going to, with the same base, we're going to subtract the exponent. So there is a shifting, a translation taking place. That is, if it's minus, it shifts right 3 units. Okay. Let's have number 8. F of x equals 2 to the power of x, and g of x is negative 2 times fx. So g of x is negative 2 times f of x, which is 2 to the power of x. So negative 2 times 2, that would be negative 4 to the power of x. There is a reflection across the x-axis. And dilation. Vertical dilation by a factor of, what is our factor here? 2. Factor of 2. All right. Let's have B. Evaluate the function of the given input values. Let h of x is 5 times 2 to the power of x minus 2. Find h of 1. Okay, so h of 1 would be 5 times 2. We replace x with 1. So that would be 1, 2 to the 1 half. All right. Remember the exponent unit fraction? We can change the 1 half, 2 to the 1 half, as a square root of 2. Okay? So your answer is 5 square root of 2 in this case. Let h of x equals 2 times 3 to the power of x over 5, where h of find h of 2. So h of 2 will be 2 times 3 to the power of 2. Replace the x with 2 to the power of 2/3. So this will be 2 times 3 to the power of 2/3. Let's use the unit fraction of exponential. This will be the cube root of 3 raised to the second power. The denominator pertains to the root. The numerator is our exponent. So this would become 2 times cube root of 3 squared, that is 9. Okay, 2 to the... Oh, that's pip root. Sorry, I didn't notice it. Hold on, I will just erase everything here. I just learned. I just look at it. So this is 2 to the fifth power. So we have 2 times fifth root of 3 squared. So that would become 2 times fifth root of 9. Okay, got it. H of x equals 5 times 4 to the power of x over 4. Find h of -2. So that would be 5 times 4, -2 over 4. Okay, unit fraction and negative exponent. So we're going to rewrite that. Make the exponent positive by flipping, get the reciprocal to make it into positive. Okay, so this would be 5 times 1 over, this is 4th root of 4 to the power of 2. So that would be 5 times 1 over 4th root of 16. Okay? What is 4th root of 16? That is 2. Right? 2 times 2 times 2 times 2. So that would be equals to 5 times 1 half. Your answer is 5 over 2. Okay. Let's do number 4 here. H of x is 6.6 times 7, x over 3. So find h of -1. So that will be 6 times 7, -1 over 3. Okay. We have a negative exponent. So flip, get the reciprocal to make it into a positive. So that would be 6 times 1 is 6. Over, how would we convert 7 to the power of 1/3? That is cube root of 7. Okay, so we're making, using the radical form. Okay, let's do this. A lake in the Cascade Mountains has frozen over during the winter over the winter. Okay. As spring brings warmer weather, the ice sheets begin to melt. The table below gives the area of ice in square feet at various times in days since the beginning of the spring. So you have time, days, 0 days, 1 day, 2 days. Area is 2.5 million of square feet when it's 1 day, 2 million of square feet. When it's 2, it's 1.6 millions of square feet. The area of the ice can be modeled by the function a sub t equals at squared. Okay, we should remember that. Where a sub t is the area in square feet at time t days since the beginning of the spring. Use the given data to write two equations that can be used to find the values of constant a and b in the expressions of a times t. Okay, let's look at the table. Remember, we are dealing with this function a times t equals a b to the power of t. So finding values for constants a and b, we might as well like use the a. Maybe we can use a to the a times b to the power of the first day 0, where we have the area which is equals to 2.5. Okay, or we could use a times b to the first, where it is equals to 2 right here. Or we could use a b to the power of 2, which is equals to 1.6. We can use either of these three to find the values for a and b. Okay, find the values of a and b, then write the expressions for a times a sub t. Okay. There are several ways in doing that. In finding a, the factor, we could get the common ratio, like dividing 2 over 2.5, that is equals to 0.8. Then 1.6 over 2, that's equals to also 0.8, right? Then we know the value of b. That means we can write it in terms of choosing here, or this. Okay, so let's say a is 2.5. That means b is raised to the 0 power. That means 2.5 b. We could have 2.5 b equals to, then b would be 2 over 2.5. b would be equals to 0.8. Or you can use this directly, the ratio that I'm doing for that. So by using a sub t, you can have 2.5 times b to the power of t, whatever time we are using. Is it 0, 1, 2, 3, and so on? Use the given data to find the average rate of change of the area from t equals 0 to t equals 2 days. Show the computation that lead to your answer. since there are two time that we are doing here, when t equals 0 and t equals 2, might as well we could use the change in time with respect to the change of, number of days. So when a is 2 minus a of 0, what is it when it's 2? It's 2 when a of 0, it's 0. That would be equals to 16, 1.6, I mean. Let's look at the table. Okay, that's 1.6 when it's 2. Minus, when it's 0, it's 2.5. Over 2. I'm getting my calculator here. So we have 1.6 minus 2.5. That's equals to negative 0.9 divided by 2. We come up with a negative 0.45 million of square feet per day. Or we could say, what is 0.45 million? That's negative 450,000 square feet. That's per day. All right. Interpret the meaning of your answer from part C as the context of the problem. So we could say on average, as the time increases, since we start from 0 then to 2. So what have we seen? From 0 to 2 days, the area of the ice decreases by 450,000 square feet per day. Right. That's it. Use the average rate of change found in part C to estimate the area of the ice in square feet at the time of t equals 3 days. So this time, it's 3 days. So we're going to use that. What we did is getting the rate of change and using this y equals y sub 1 plus m times x minus x sub 1, where we can have a when it's 0 minus 0.45 t minus 0. We can use that. Or y when a sub 2 minus 0.45 t minus 2. So for t equals 3, either of these equations we can use. So if I say if I use y equals 2.5 minus 0.45 times 3, then I would have, by multiplying it all and subtracting, doing math, 2.5 minus 0.45 times 3, we have a 1.15. The area of the eyes time t equals 3. Remember, it has been reduced as days move on. 3 days is 1.15 million square feet. Questions like this are usually questions that come out in the AP Precalc exam. Does the model found in Part B demonstrate? Let's go back to Part B. Demonstrate an exponential function, exponential growth or decay. Give a reason for the answer, whether growth or decay. So let's look at our A. What can we say our A in the table? A are greater than 0. How about the B? The ratio is between 0 and 1. So because of this reason, the model A sub t demonstrates exponential decay. All right, that's it. Because of that, so when you give out reasoning, give on the basis of the A and the B, and you will not get lost to know whether it's growth or decay. Okay, let me say this: if I can do it, so can you. Please don't forget to hit the like button and subscribe. See you in my next video.